Now, in this lecture, we will find the area of the green triangle. In the drawing, we have a triangle ABC that is an equilateral triangle, and inside the triangle ABC we have the green triangle that is also a right triangle because angle FDE equals to 90 degrees, and we know that AF equals to BF and BD equals to 2 units and DC equals to 4 units, and we want to find out the area of the green triangle. As you have already know, all the angles in an equilateral triangle equals to 60 degrees. So angle BAC equals to 60 degrees, and angle ABC equals to 60 degrees, and also angle BCA equals to 60 degrees, and all the sides of an equilateral triangle are equal to each other, so AB equals to BC equals to EC. Okay, so I'll write it down that AB equals to BC equals to AC. Okay, but okay, so AB equals to BC equals to AC, and but what is the size of BC? BC equals to BD plus DC. Again, BC equals to BD plus DC. Okay, but BD equals to 2 units and DC equals to 4 units. So the size of BC is 2 plus 4. So the size of BC is 6 units. Okay. Therefore, the size of all the sides of the equilateral triangle ABC equals to 6 units, and AB equals to BC equals to AC equals to 6 units. Okay, and we also know that AF equals to BF. So if we define AF as X, then BF that equals to AF will be defined also as X. Okay? But we know that from one side AB equals to 6 units. Okay? AB equals to 6 units from one side, and from the other side AB equals to AF plus BF. Okay, AB equals to AF plus BF. That is to say, AB equals to AF that is X plus BF that is also X. In other words, AB equals to 2X. Okay, AB equals to 2X. Okay, so we got that AB equals to 6 units and also it equals to X. So from this equality, we can derive the equality that states that 2x equals to 6 units. Okay, and if 2x equals to 6 units, we can divide this equality by 3 and we will get that x equals to 3 units. Okay, x equals to 3 units. That means that AF also equals to 3 units, and AF that equals to BF equals to 3 units. That is to say, BF also equals to 3 units. Okay? In the next step, we will define FD as A. That is to say, FD equals to A, and we will define DE as B. That is to say, DE equals to B. And we will find the value of FD according to the law of cosines. What is the law of cosines? Okay, we will use the law of cosines in order to find the value of FD. So, what is the law of cosines? First of all, the law of cosines applies to any triangle. So we can say that in any triangle, that is to say, you can use the law of cosines in any triangle. Okay, so if we have triangle or if the length of this side of the black triangle equals to A, and the length of this side of the black triangle equals to B, and the angle between side A and side B of the black triangle is theta, and this side of the length of this side of the black triangle equals to C, then according to the law of cosines, the following relationship exists between the sides of the black triangle to its angle theta. C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay, so in any triangle, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay? Again, C square equals to A square plus B square minus 2 times A times B times cosinus theta. Okay, so because of the fact that the law of cosines is true for any triangle, we can apply the law of cosines in triangle FBD. Okay, we can apply the law of cosines in the small triangle FBD. Okay, so according to the law of cosines in triangle FBD, this small triangle, FD square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, so in triangle FBD, the implementation of the law of cosines is that FD square equals to FB square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay? But what is FD? What is the value of FD? According to our definition, the value of FD is A. So FD square is A square equals to BF square. What is the value of BF? BF equals to 3 units. So BF square is 3 square. 3 square is 9 plus BD square. BD equals to 2 units, so BD square is 2 square, and 2 square is 4, minus 2 times BF is 3, times BD is 2, and cosinus 60 degrees equals to 1 over 2. So, in total, we got that A square equals to 9 plus 4 minus 2 times 3 times 2 over 2. Here 2 over 2 is 1, so 2 is cancelled, and what is left is A square equals to 9 plus 4, that is 13, minus 2 times 3 is 6. So we got that A square equals to 13 minus 6. Okay, A square equals to 13 minus 6, and 13 minus 6 is 7, so A square equals to 7. Okay, and we can take a root out of this equality, and we will get that A equals to the root of 7 units. Okay, so we found out the value of A. A equals to root of 7 units, so we can write here that A equals to root of 7 units. Okay, in the next step we will define angle BFD as theta, angle BDF will be defined as alpha, angle EDC will be defined as gamma, and angle DEC will be defined as beta. Okay, and we will find the value of sinus theta according to the law of sines. What is the law of sines? Okay, we will find out the value of sinus theta according to the law of sines. First of all, the law of sines true for any triangle, so we can write here also that in any triangle, so we can use the law of sines in any triangle. So if we have triangle if the length of this side of the black triangle equals to A, and the length of this side of the triangle equals to B, and the length of this side of the black triangle equals to C, this angle equals to alpha, this angle equals to beta, and this angle equals to gamma. Then the following relationship exists between the sides of the black triangle to its angles. A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. And again, it is true in any triangle. This equality is true in any triangle, so especially it will be true in triangle FBD, so we can apply the law of cosines in triangle FBD. Okay, I will repeat again in the law of sines. A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, so we will apply the law of sines in triangle FBD. So according to the law of sines in triangle FBD, BD over sinus theta equals to df over sinus 60 degrees. Again, according to the law of sines, BD over sinus theta equals to df over sinus 60 degrees. Okay, that is the implementation of the law of sines in triangle BFD. Okay, but what is the value? What is the value of BD? BD equals to 2 units, and sinus theta is actually the value that we want to find out, and we will find out the value of sinus theta according to this equality. So sinus theta will remain as sinus theta. 2 over sinus theta equals to df. What is the value of df? df equals to a, and a, we have already found out that a equals to the root of 7 units. Root of 7 units over sinus 60 degrees. What is the value of sinus 60 degrees? Sinus 60 degrees equals to the root of 3 over 2. So, in total we got that 2 over sinus theta equals to the root of 7 over root of 3 over 2. Here we can move 2 to the numerator and root 3 to the denominator. Okay? We will get that 2 over sinus theta equals to 2 times root 7 over root 3. Okay, we did the simple arithmetic, and we got that 2 over sinus theta equals to 2 times root 7 over root 3. Here we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of the other side of the equation, so we can cancel 2. And what left after we canceled 2? What left actually is 1 over sinus theta equals to root 7 over root 3. So after we cancel 2, what is left is 1 over sinus theta equals to the root of 7 over root 3. Here we will multiply this equality by sinus theta, and we will get that 1 equals to root of 7 over root 3 times sinus theta. Okay, we got that 1 equals to root 7 over root 3 times sinus theta. Here we will multiply this equality by root 3, and we will get that root 3 equals to root 7 times sinus theta Okay, we got that root 3 equals to root 7 times sinus theta, and we will divide this equality by root 7 in order to get the value of sinus theta. And we will get that the value of sinus theta is actually root 3 over root 7. So we found out the value of sinus theta. Sinus theta equals to the root of 3 over root 7. In the next step, we will find out the value of cosinus theta according to the first trigonometric identity. The following trigonometric identity is sinus theta squared, and we will use the following trigonometric identity in order to find out the value of cosinus theta. The trigonometric identity is sinus theta squared plus cosinus theta squared equals to 1. Okay, we will use this trigonometric identity in order to find out the value of cosinus theta. Here we will subtract from this identity sinus theta squared, and we will get that the value of cosinus theta squared equals to 1 minus sinus theta squared. Okay, we subtracted sinus theta squared from this equality, and we got that cosinus theta squared equals to 1 minus sinus theta squared. In the next step, we will take a root out of this equality, okay, and we will get that cosinus theta equals to the root of 1 minus sinus theta squared. Okay, so we found that the value of cosinus theta is the root of 1 minus sinus theta squared. Okay, but we have already found out that the value of sinus theta is root 3 over root 7. Okay, so we can write here that the value of sinus theta is actually root 3 over root 7. Okay, so if the value of sinus theta is root 3 over root 7, then the value of sinus theta squared will be 3 over 7. Okay, so the value of sinus theta squared will be 3 over 7. Okay, after we found out the value of sinus theta squared, we can substitute sinus theta squared by 3 over 7, because sinus theta squared equals to 3 over 7. Okay, and in this way we will find out the value of cosinus theta. Okay, so cosinus theta equals to the root of 1, and instead of sinus theta squared we will write 3 over 7. Okay, we got that the value of cosinus theta equals to 1 minus 3 over 7. 1 minus 3 over 7 is 4 over 7. So we got that the value of cosinus theta equals to the root of 4 over 7. Okay, the value of cosinus theta is the root of 4 over 7. Root of 4 is 2, so I write it down. So in total we got that the value of cosinus theta is 2, that is the root of 4 over root of 7. That is the value of cosinus theta, and we have already found out that the value of sinus theta is the root of 3 over root of 7. So we actually found out the values of cosinus theta and the value of sinus theta. Okay, we found out the value of cosinus theta and sinus theta. So in the next step we will create 4 equations. Equation number 1 will be in relation to triangle FBD. In triangle FBD, the sum of the angles in triangle FBD equals to 180 degrees. So what are the angles of triangle FBD? They actually 60 degrees plus alpha plus theta equals to 180 degrees. Okay, so actually our first equation states that the sum of the angles in triangle FBD equals to 180 degrees. Then we will create the second equation, and we will focus on triangle EDC. Okay, and the second equation states that the sum of the angles in triangle EDC equals to 180 degrees. So what are the angles of triangle EDC? The angles are 60 degrees plus gamma plus beta, and the sum of those 3 angles equals to 180 degrees, and it is actually true for any triangle, and especially in triangles EDC and triangles BDC and triangle BFD, that the sum of the angles of those triangles are equal to 180 degrees. So we created the second equation that states that the sum of the angles in triangle EDC equals to 180 degrees. Okay, in the next step we will add equation number 1 to equation number 2, and we will create equation number 3 that is actually the addition of equation number 1 to equation number 2. Okay, so according to equation number 3, 60 degrees plus 60 degrees is 120 degrees. Here we have theta alpha plus theta plus alpha plus theta plus gamma plus beta equals, and the sum of equation number 1 with equation number 2 on the other side of the equation is 180 degrees plus 180 degrees equals to 360 degrees. Okay, so equation number 3 we can subtract 120 degrees from both sides of the equation, and we will get that 120 degrees minus 120 degrees is 0, and we have here alpha plus theta plus gamma plus beta equals to 360 degrees minus 120 degrees is 240 degrees. Okay, so we got in equation number 3 that the sum of the angles of all the angles, actually of the two triangles, so the sum of alpha plus theta plus gamma plus beta equals to 240 degrees. And in the next step we'll create equation number 4 that states that at a certain point, if we look at a straight line or line segment, the sum of the angles in the upper side of line segment or straight line at a certain point equals to 180 degrees. That is to say, if we look at point D, the sum of the angles in the upper side of line segment BC equals to 180 degrees. So, what are the angles in the upper side of line segment BC at point D? They are actually alpha plus 90 degrees plus gamma, and the sum of those angles equals to 180 degrees. So we can write down that alpha plus gamma plus 90 degrees equals to 180 degrees. Okay, alpha plus gamma plus 90 degrees equals to 180 degrees. Actually, we can subtract 90 degrees from the fourth equation, and we will get that alpha plus gamma equals to 90 degrees. Okay, so question number 4 states that alpha plus gamma equals to 90 degrees. Okay, but if we look at the question number 3, we have alpha plus gamma also in equation number 3. That is alpha and that is gamma. So according to equation number 4, we can substitute alpha plus gamma by 90 degrees because alpha plus gamma equals to 90 degrees. Okay, so we will substitute alpha plus gamma by 90 degrees in equation number 3. Okay, and we will get that 90 degrees plus theta plus beta equals to 240 degrees. Okay, we substituted alpha plus theta in equation number 3 by 90 degrees, and we got that 90 degrees plus theta plus beta equals to 240 degrees. Here we will substitute from equation number 3 90 degrees, and we will get that theta plus beta equals to 150 degrees. Okay, theta plus beta equals to 150 degrees. Here we will subtract theta from equation number 3, and we will get that beta equals to 150 degrees minus theta. Okay, according to equation number 3, beta equals to 150 degrees minus theta. But if beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus 150 degrees minus theta. Very simple. So we'll write it down that sinus beta equals to sinus 150 degrees minus theta. Okay, we got this equality, and in order to find out the value of sinus 150 degrees minus theta, we will use the second trigonometric identity that states that the value of sinus alpha minus beta, the value of sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Okay, so actually our second trigonometric identity states that the value of sinus alpha plus sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Okay, and we'll use this identity in order to find out the value of sinus 150 degrees minus theta when we substitute alpha by 150 degrees and beta by theta. So we will use this identity, and we will find out that the value of sinus 150 degrees minus theta according to this identity is actually sinus 150 degrees times cosinus theta minus cosinus 150 degrees sinus theta. Okay, so we actually use this trigonometric identity in order to find out the value of sinus 150 degrees minus theta. Okay, and what is the value of sinus 150 degrees? The value of sinus 150 degrees is 1 over 2. And we actually found out that the value of cosinus theta is 2 over root 7 units, and the value of sinus theta is root 3 over root 7. Okay, so we have here sinus 150 degrees times cosinus theta, and the value of cosinus theta is 2 over root 7 minus cosinus 150 degrees. The value of cosinus 150 degrees is minus root 3 over minus root 3 over 2 times sinus theta. As I've already shown you, the value of sinus theta is root 3 over root 7 so we actually got that in total 1 over 2 times 2 over root 7. So here we have 2 in the numerator and 2 in the denominator of this expression, so 2 can be cancelled. Minus, here we have minus times minus, minus times minus is plus, and we have here root 3 times root 3. Root 3 times root 3 is 3. So I write it down. One over root 7 plus 1 over root 7 3 over 2. So we got that 1 over root 7 plus 1 over root 7 times 3 over 2. That is the value of sinus 150 degrees minus theta, but sinus 150 degrees minus theta equals to sinus beta. So actually what we found here is the value of sinus beta. Okay, so in the next step we will take out a common factor 1 over root 7 from this expression, and we will get that the value of sinus beta equals to the 1 over root 7 is the factor that we took out of this expression, and inside the brackets we will have 1 plus 3 over 2. Okay, so we found out that the value of sinus beta is 1 over root 7 times 1 plus 3 over 2. 1 plus 3 over 2 is 2.5, and 2.5 is 5 over 2. Okay, so I will write it down. So we actually found out the value of sinus beta. Sinus beta equals to 1 over root 7 times 5 over 2. Okay. Again, the value of sinus beta is 5 over root 7 times 2. Okay? So after we found out the value of sinus beta, you actually can find the value of B by implementing the law of sines in triangle EDC. Okay, so in triangle EDC, ED over sinus 60 degrees equals to DC over sinus beta. Again, according to the law of sines in triangle EDC, ED over sinus 60 degrees equals to DC over sinus beta. Okay? According to the law of sines in triangle EDC, ED over sinus 60 degrees equals to DC over sinus beta. Okay? But what is the value of ED? The value of ED is B, so we can substitute ED by B. And what is the value of sinus 60 degrees? The value of sinus 60 degrees is root 3 over 2. What is the value of DC? DC equals to 4 units. And we have already found out that the value of sinus beta is 5 over root 7 times 2. Okay? So we can write down the value of sinus beta in this equality. So in total we got that B over root 3 over 2 equals to 4 over 5 over 2 times root 7 . Here we will move 2 times root 7 to the numerator and 5 to the denominator, and we will move 2 of this expression to the numerator and root 3 to the denominator. Okay? So we got that 2b over root 3 equals to 4 times 2 times root 7 over 5. First of all, we have 2 in the numerator of this side of the equality, and we have 2 in the numerator of the other side of the equality, so we can cancel 2. So what is left after we cancel 2 is b over root 3 equals to root 7 times 4 over 5. Okay, that is what is left after we cancel 2. Here we will multiply this equality by root 3 in order to get the value of b. Okay, we will get that b equals to the root of 7 times root 3 times 4 over 5 units. So we found out the value of b. b equals to the root of 7 times root 3 times 4 over 5. But we have already found out the value of a. a equals to the root of 7. So we can write here that a equals to root 7 units. And we actually know that the area of the green triangle equals to the base of the triangle, that is b, times the height to the base, that is a, over 2. Okay, so the area of the green triangle FDE equals to the base of the triangle, that is b, times the height to the base, that is a. You should remember that the height must create 90 degrees with the base, and a indeed creates 90 degrees with the base b. The angle between a and b is 90 degrees, so a is indeed the height to the base, so it is b times a over 2. Okay, so the area of the green triangle equals to b times a over 2, and we have already found out the value of a and b, so the only thing that is left is to substitute a by root 7 and to substitute b by the value of b that we have already found. Okay, so the area of the green triangle FDE equals to a is root 7 times b is root 7 times root 3 times 4 over 5, all divided by 2. Okay, that is the area of the green triangle. We know that root 7 times root 7 is 7, and 4 over 2 is 2, so I write it down. So the area of the green triangle FDE equals to 2 times 7 times root 3 over 5. Okay, so the area of the green triangle is 2 times 7 times root 3 over 5. 2 times 7 is 14. So I write it down. So we will get that the area of the green triangle FDE equals to 14 times root 3 over 5 square units. Okay, so the area of the green triangle FDE equals to 14 times root 3 over 5 square units. or in terms of numbers, the area of the green triangle FDE equals to 4.85 square units. Okay, the area of the green triangle FDE equals to 4.85 square units. Again, the area of the green triangle FDE, this green triangle, equals to 4.85 square units. Okay, so now I will summarize the lecture. We actually wanted to find out the area of the green triangle FDE. The green triangle is also right triangle because of the fact that angle FDE equals to 90 degrees. And the green triangle is inside an equilateral triangle. Triangle ABC is an equilateral triangle. That is to say, all its three angles equals to 60 degrees. Angle BAC equals to 60 degrees. Angle ABC equals to 60 degrees. And angle ACB equals to 60 degrees. And we also know that AF equals to BF, and BD equals to 2 units, and DC equals to 4 units. And we want to find out the area of the green triangle FDE. Okay. First of all, what is the size of BC? BC equals to BD plus DC. Again, BC equals to BD plus DC. Okay, but we know that BD equals to 2 units and DC equals to 4 units. So BC equals to 2 plus 4. So the size of BC is 6 units. And as I've already told you, all the sides of an equilateral triangle are equal to each other. So if BC equals to 6 units, then AB also equals to 6 units, and AC also equals to 6 units. Okay? So we can write down that AB equals to BC equals to AC equals to 6 units. But we also know that AF equals to BF. It is given us in the question. So if we define AF as X, then AF that equals to BF, then BF also will be X, because AF equals to BF. So actually, what is the size of AB? From one side, AB equals to 6 units. But from the other side, AB equals to AF plus BF. That is to say, AB equals to AF that is X plus BF that is also X. Or in total, AF equals to 2X. So we got this equality that from one side AB equals to 6 units, and from the other side AB equals to 2X. So from this equality we can derive the equality that 2x equals to 6, and if we divide this equality by 2, we will get that x equals to 3 units. So actually AF that equals to x equals to 3 units, and BF that also equals to x equals to 3 units. Okay, in the next step we defined FD as A, that is to say FD equals to A, and we defined DE as B, that is to say DE equals to B, and we found out the value of FD that equals to A by the law of sines. What is by the law of cosines? Okay, we implemented the law of cosines in triangle FBD in order to find out the value of FD that equals to A. What is the law of cosines? The law of cosines is true for any triangle. So in any triangle, C square equals to A square plus B square minus 2 times A times B times cosinus theta. Okay, so we actually implemented the law of cosines in triangle FBD. In triangle FBD, we can say that according to the law of cosines, FD square equals to FB square plus BD square minus 2 times FB times BD times cosinus 60 degrees. Okay, FD square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, but we know that FD equals to A, BF equals to 3 units, and BD equals to 2 units. And so we have the values of all the variables here, and the only missing variable is here is FD that equals to A. Okay, so we put the data inside this equality, and we found out that the value of A is root of 7 units. Okay, A equals to root of 7 units. Okay, and in the next step we defined angle BFD as theta and angle FDB as alpha, and we also defined angle EDC as gamma, and we defined angle DEC as beta. Okay, and in order to find the value of sinus theta, we implemented the law of sines in triangle FBD. What is the law of sines? The law of sines is true for any triangle, so in any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, so we implemented the law of sines in triangle FBD. So in triangle FBD, BD over sinus theta equals to DF over sinus 60 degrees, according to the law of sines. In triangle FBD, BD over sinus theta equals to DF over sinus 60 degrees. We know that the value of BD is 2. We have already, okay, and sinus theta is the value that we want to find out. DF equals to the root of 7 units, and sinus 60 degrees is root 3 over 2. So the only missing variable is sinus theta. So we solved this simple equality and we found out that the value of sinus theta is root 3 over root 7. In the next step, we found out the value of cosinus theta by implementing the first trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. Okay? We subtracted sinus theta squared from this equality. We got that cosinus theta squared equals to 1 minus sinus theta squared. We took a root out of this equality and we got that cosinus theta equals to the root of 1 minus theta squared. But we have already found out that the value of sinus theta is root 3 over root 7. So we can, and so if sinus theta equals to the root of 3 over root 7, then sinus theta squared equals to 3 over 7. Okay, so we can substitute sinus theta squared. We can substitute sinus theta squared in this equality by 3 over 7 because sinus theta squared equals to 3 over 7. So we got that cosinus theta equals to the root of 1 over 3 over 7. 1 minus 3 over 7 is 4 over 7. So we got that cosinus theta equals to the root of 4 over 7. And we found out that the value of sinus theta, the value of cosinus theta equals to 2 over root 7 because the root of 4 is 2, so cosinus theta equals to 2 over root 7, and we have already found out that the value of sinus theta is root 3 over root 7. Okay? In the next step, we created 4 equations. The first equation relates to triangle FBD. The first equation states that the sum of the angles in triangle FBD equals to 180 degrees. Okay? The sum of the angles in triangle FBD equals to 180 degrees. Then we created the second equation in relation to triangle EDC. The second equation states that the sum of the angles in triangle EDC, this triangle, equals to 180 degrees also. Okay, so the second equation is that the sum of the angles in triangle EDC equals to 180 degrees. Then we added equation number 1 to equation number 2, and we created equation number 3. Equation number 3 is the addition of equation number 1 to equation number 2. Okay, then we also created equation number 4 that states that at a certain point in any straight line or line segment in the upper side, the sum of the angles equals to 180 degrees. So if we focus on point D and line segment BC, the sum of the angles in the upper side of BC at point D equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, so according to equation number 4, the sum of the angles at a certain point at the upper side of any straight line or line segment equals to 180 degrees. That is to say, alpha plus gamma plus 90 degrees equals to 180 degrees. Okay, from equation number 4 we got that alpha plus gamma equals to 90 degrees. So we can substitute alpha plus gamma in the third equation by 90 degrees. So we got that theta plus beta equals to 150 degrees, or beta equals to 150 degrees minus theta. So if beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. Okay, so in order to find out the value of sinus 150 degrees minus theta, we used the second trigonometric identity that states that the value of sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta times cosinus alpha. Here we substituted alpha by 150 degrees and beta by theta, and we found out that the value of sinus 150 degrees is actually equals to sinus beta, or the value of sinus beta is actually 5 over root 7 times 2. Okay, so after we found out the value of sinus beta, we implemented the law of sines in triangle EDC in order to find out the value of DE, that is B. According to the law of sines in triangle EDC, ED over sinus 60 degrees equals to DC over sinus beta. Okay, in triangle EDC, according to the law of sines, ED over sinus 60 degrees equals to DC over sinus beta. Actually, we know that DC equals to 4 units. We have already found out the value of sinus beta, that is the value of sinus beta. And sinus 60 degrees equals to root 3 over 2, so the only missing variable here is B. So we solved this simple equality and we found out that the value of B is actually root 7 times root 3 times 4 over 5. And we have already found out the value of A. A equals to root 7. Okay, so we know the value of B and A, and the area of the green triangle equals to the base of the triangle, that is B, times the height to the base, that is A, over 2. And the height indeed creates 90 degrees with the base B, so A is the height and B is the base. So the area of the green triangle equals to B times A over 2, and we have already found out the value of A and B, so the only thing that left is to substitute A by root 7 and to substitute B by the value of B that we have already found, and to multiply A by B and to divide it by 2. So we found out that the value of the area of the green triangle is actually 14 times root 3 over 5 square units. So in terms of numbers, the area of the green triangle equals to 4.85 square units. Again, the area of the green triangle equals to 4.85 square units. Okay, thank you very much.